Let's start. So, in the today's session, the we are going to discuss about RNN. First, we will get some introduction to RNN. Then we will learn how to build a basic RNN network, and further we will explore LSTM networks. And let in the last part, you have to do a hands-on, which in which you are provided with a data set, and you have to implement LSTM. Uh, okay, so let's begin. Uh, in the today's lectures, we learn a lot mathematical complexity of RNN, and in today's lab session, we are going to see how to implement RNN. There is lots of maths behind this, but implementation is not that much critical part. It's just a few line of codes, and it start generating. So the key concept I want to introduce you about RNNs are: first one is sequential data. The speciality of RNN is the it learns pattern also, not only features, but the sequence in which they are structured. It also learns that there is a hidden state. We know there is a black box technique in deep learning, and consider this as a black box. We knew things what happens in that box, but how, we still don't know. And that's where what it right, but we provide previous input, right? तो उससे इंटीग्रेट होते होते वो सीक्वेंस लर्न कर जाता है. आर यू गेटिंग मी? Okay, we will cover that later. So let's start. First, building. Let's begin with building with RNN. And yeah, here are basic libraries we are going to implement with PyTorch. Import all the necessary libraries, matplotlib for visualization. It's done. So what we are going to do, we are constructing a sine wave function. uh, we know sine wave function, right? It range between 0 to 1, right? No, -1 to 1. Yes. So let's begin. First, we introduce sequence length. Basically, how many data points we want to consider in this sine wave function. We take a timeline of 0 to 2 pi. You can do with further also. Later, we are providing input size as one at we are learning one feature at a time to the neural network. So let's run the code. Number of steps equal to 15. Within 0 to 2 pi range, here we are going to see 15 points. Uh, okay. So this is basic theory behind the RNN structure. What is RNN cell? What is a fully connected layer? We learn in the lecture. Okay, so this is class simple RNN. We define our class. Then we give input as a hidden size to our RNN class, and parameters are input size, hidden size, and number of layers. So input size and number of layers are one, because we are processing one input at a time, and hidden size we can set according to our problem statement, like how much complexity we want to set in the problem. So yes, so here we set to 16, and yeah, the learning rate to 0.001. We are setting mean square error loss as a criteria, and Adam optimizer. So let's train on 100 epochs. So basically we are defining very simple function, sine wave function, so it won't take that much time. Easily we can see uh, model is trained, and we want to generate predictions here. So these are our predictions. You can see blue points are actual labels, and orange ones are the predicted ones. In the starting there is some misalignment, but in the between it's fine. So these orange points are the predictions of our RNN model. So we are taking it to some next level. We will see how LSTM is implemented in this lab session. So we will begin with simple data. The here in the training data, we took two sentences. The dog ate the apple, and everybody read that book. It is split, and we had provided position tagging, like a noun, verb, adjective, and these two sentences we are going to train. We first tokenize them, like we created a library and provided indexing to the input data. You can see the neural network embedding to link is provided here to learn about more parameters and other functions. Here you will see documentation of functions. Okay. So yeah, here we have built LSTM tagger module. Basically, the same for what we have created a dictionary, and we are going to implement it. Basically, this model is going to learn how position is tagged in the training data and process. After processing for the given input, it will going to give predictions. Is there any question? Um, we will have uh, okay. We will have lecture at on LLM session after 4, but I don't think there will be AI enabled platform session. We are going to have lecture of Professor Aditya. Okay, so yeah, here we set embedding dimensions to 6 and hidden dimensions to 6 also. You can explore by changing learning rate, changing hidden dimensions. But if you increase hidden dimensions too much, it is going to be increase the complexity of model. Since we are providing a very small data, we don't need that much. It can lead to overfit the model. Yeah, so let's run. Here we have set 300 epochs. You can change, but if you see, there is not that much change after 50 epochs. Its loss is close to 1.0234. And here are the embeddings we get. So there is exercise here. Uh, you Do you guys know Shakespeare data? Yeah. So we have done implementation of LSTM on that data. So for that, we need to install this library Unite code, and we will download the data from this site, this GitHub repo of Karapati, Karpati, whatever. Okay. So data is downloaded. This function character tensor, it convert our string to tensor in the form of zeros and ones. So here we have defined a RNN model for Shakespeare data. We have set input size as the length of the our data, and hidden size we can set according to us, whatever we want to put. And output layers, yes, the output size we want. So let's evaluate. As you see, model is started to training and giving some outputs. I hope you guys are following me. This code is not mine actually. I have referred it. I provided the link in the last of the collab file also. But it is, I found this content is very easy to implement and understand from the basics. The next problem I'm going to provide you is my first project, which I implement when I tried first time RNN and LSTMs. So I want you to guys go through it. It's basically sentiment analysis problem. The basic part of RNN model is, yeah, you have to give input size. There is a hidden size, but hidden size multiplies itself. So you have to provide accordingly, according to your data and your problem and output size. These are the basic things only. You should work on different projects. You will get to learn more. That's the idea. You should learn. That's how. Explaining, let it complete. So while training, I will show you the data set of the following problem. The problem is toxic comment classification. In the data, you are provided with comment ID, comments, and the rating of that comment, how like the toxicity, whether it is moderately, it is hit rate, or it is very toxic or non-toxic, it is fine. So its application are used manywhere, like uh, on the many social media platforms, people can abuse openly. So to avoid these things, these problems is invented. So in this folder, I have provided training data and testing data. We will work on training data, and further you can predict the model predictions on test data to generate a label. This is multi-class classification problem. So our code is run totally. Let's proceed. These are the important libraries. No, we are not using GRU. It is no, no, no. I want you to explore GRU model. We are perform on LSTM, but you it's I want you to encourage to see GRU models. Implementation is not going to be that much difficult part if you follow the documentation. So let's train our data, like load our data. Okay, okay, I have to download it. Why? Okay, first we have to download the data, and then it will going to load the data in our training. What's the error here? Isn't it downloading? Okay, okay. Let me see what's the problem is. I think I have to do manually. Are you guys able to load the data? Okay, then follow the link and upload it manually. I don't know why it's not working. I have to check, but okay, let me restart the session. Okay, okay, fine. It's so yeah, as I mentioned, these are the features of the data frame. ID is mentioned to you. Further, it's comment, and later there are five to six classes are there, like toxic, severe toxic, options, threat, insult, identity hit, or no toxicity. Let's fit our data in data loader. Process text. Why is this happening? I don't know. Okay, fine. We will come back here later. Okay. So these are the non-toxicity values. Basically, around 2,000 columns are non-toxic, and sorry, 15,000 are non-toxic, and 1,600 are toxic comments. So we are going to separate this. It's not like this. It should be. I don't know. Okay, so 16,000 columns are fed in our train data. No, Okay, there is something problem with the data file, but I will explain you in short what I have done and what I want to do. I will fix these things by today. So what I have performed is basically when I load the data set, I found that within training data, more than 1 lakh samples are only about this comments are non-toxic, and rest are categorized in the other classes. But to train a model, it is necessary to you have to keep the balanced data, or else your model will get overfit for only one class. So to avoid that, I resample it. And what I have performed, like I keep 15,000 samples for non-toxic comments, and rest of the classes are fine for me. So after reshaping my data, I get these sampling of the comments. What I have comment ID, I have their comment and features. So in this class, I define a pre-processed text. So it process on sentence text. What it does, it removes some punctuation, commas, space, or random capitalization. It convert all into small cap. And yeah, also it removes empty spaces and all, and it returns us a clean strip. So after this pre-processing, what I have done is, yeah, in the I convert into x and y. So in the x column, I feed with comment text, which is going to feature of the data. And in the y column, I provided its classes and labels. So how it is labelized. And in the later part, this is the way I split into train test data. So for the test size, I put zero point 0.2 and training size at 80% of the data for training. This is different from the test data set I have mentioned in the data set. So basic is to validate the things. Then I implement the tokenizer. So this I have used glove embedding and use basic English corpus to get tokens. What tokens are? Tokens are the unique words we see. I will show you different stuff also on these things. Don't worry. I don't know why this didn't work. I will fix it and provide update the GitHub also. Then in the later part, yeah, I tokenize the sentence to extract the important things only, to avoid unnecessary part. And then this is LSTM architecture. You can see I get it's and these are embedding matrix. In the embedding matrix, I provide all the vocabulary vectors, and it is going to be little complex things because it's a huge data. In the further part, we train the data set, we convert into tensors and initialize our LSTM model with the vocabulary size, embedding dimensions I provided. And BC loss I have used in my project with the learning rate of 0.001. You can use a different loss function. So I guess NLL loss is there, or try with different loss functions. You will see. So this is training loop and evaluation. Okay, I will fix it, but till that I have something interesting for you. Actually, the problem is in data itself, because it is not loading total data set. I don't know why. It's giving 16,000 only. डाउनलोड हो रहा है कहाँ पे? ओके, हाँ वो कुछ तो प्रॉब्लम है, मुझे भी समझ नहीं आ रहा. हाँ एग्जैक्टली, पूरा नहीं हुआ है. सो आई विल कम टू दिस पार्ट लेटर, बट आई हैव समथिंग फॉर यू. Okay, I want you guys to try on that data also, toxic comment classification. It's a sentiment analysis problem. Just similar to, you will get an idea, and later you can explore more with IMDb dataset also. It's also going to be similar one. So yeah, yesterday I was exploring some more about natural language processing. So this fast AI library, I want you all to, if you guys can see, is it fine if I run here? This is the fast AI official documentation. You can find here, tutorials are also provided here. They have also their data. We have used human numbers. I will show you. Till that, this project. Yeah, it is installing. We are importing all the stuff from this library. So we are using human numbers data. This is path. You will find one is train text and valid text. This is test data, and train is for training. Okay. So basically, what this data all about is, it's 1 to 10,000 written in the words 1, 2, 3, 4, 5. If we print this up to 100, you will see all beginning from 1 to 100. What you think? How many unique numbers are present in 1 to 100? Like 1 to 10 are unique almost, but later on we use 21 in it. One is already picked. Any guess? 1 to 100, how many unique numbers can be there? नहीं, ये वाला गिटहब पे नहीं है. I will post this also, don't worry. 1 to 9, 10 value, 10 words. No, 20 is not in 1 to 9. Any guesses? नंबर्स में नहीं, जैसे हम नंबर्स लिखते हैं 1 2 3 4 अप टू 100. सो इन द 1 to 100 when you write in English, so how many unique numbers I want? Like 1 to 10 are itself unique. 11 to 20, almost everyone is unique. 11, 12 is not repeated. But if you see 21, within 21, 20 is already there in 20, and one is we pick in 1 to 10. So what do you think? How many unique numbers can be there? Any guesses? Online audience? 45, 10C2. Let's see. Interesting. Okay, so yeah, we will move ahead. Let's not stick only on one question. Okay, so this is the text. What I did, I just removed that slash n and joined them with dot. So tokens, yeah, tokens are, as I told you already, tokens are unique words. It can be word level tokenization or character level tokenization. It fits about from problem to problem. So we get 63,095 values. And among all these 63,000 values, we get 30 values as a unique values. So this is the answer within 1 to 100, including this dot, means only 29 values are unique itself. Okay. So here, what we have done is we have provided words to, we have provided basically indexing to the words. जैसे 1 को 0 दे दिया, डॉट को 1, फिर 2 को 2, 3 3 4 onwards. So it's up to 29. So all these are unique tokens in our vocabulary. And in the reverse also, because it will going to useful to convert the embeddings to words. So this is the embedding, like as I said, one is noted 0, 1 is noted with 0, dot is noted with 1, 2 is noted with 2, and onwards. Again, after 2 there is a dot, because we earlier we joined these by dots, right? If you see. Okay, so here what I have did is it's a basic problem. If we give input 1 dot 2 dot 2, so we gives it gives output should be dot, and if we provide input dot 2 dot, it will provide 3, and similarly 2 dot 3 we will get dot. This sequence will go onwards, like after that dot 3 dot gives 4, means next number. So this is the sequence I generated, and its numbering is provided here. So what, we cut this part and into like 80% for training and rest of the part for testing. Shuffle equal to false. Remember that in the natural language processing, in any problem, when you deal with text data, the position of text is important. So you have to keep shuffle equal to false. This if you shuffle the words, then it can change the meaning. So it will feed the model in wrong way. So this is the shape of our data, training data loader and validation data loader. So again, this is the RN model. Vocab size, vocab size is length of our vocab, and we provide hidden dimensions to 64. Length of our vocab is 30 because we have 30 unique tokens. You can follow me like how these coming things are coming. Again, this is epoch and scheduling learning rate. You see, accuracy is around 46%, 47%. It's not that much bad, but yeah, yeah. This is epoch and this is learning rate. If you do with 10, it will run on 10 epochs with learning rate 0.001. You can change these parameters. You see, the accuracy goes to 50%, and after three epochs, 2, 3 epochs, it's not increasing in that much. Same is coming, so it's better to stop. Our model is not optimizing it. Okay. Okay. So let's build up LSTM model for this. Here is the forget gate, input gate, cell gate, output gate. We know their functions and we provided with their parameters as input and number of hidden layers. So this is how we structure a LSTM cell when we implement it. This is the sigmoid function we learn in the today's class. This is tanh. Yeah, again, these are the parameters, vocabulary size and input, hidden dimensions. So we fade it. Here we have set matrix equal to accuracy, but you can find there is another matrix also, name perplexity, I guess. I have mentioned in the next part. It can be it can be used also. So yeah, this is LSTM on our vocabulary data. So shifting to the transformer stuff. Here I have used pre-trained transformer. Basically, transformer is a library from Hugging Face. We have used GPT-2 LM head model and GPT-2 tokenizer. It's open source model. You can find it on Hugging Face. Mm, yeah, we are going to see. This is Hugging Face. You can see lots of data set and models are here. For different tasks also you can find pre-trained models here for each task like image, text to text, document, question answering. Basically this is useful for chatbot, text to image, image to text. As we see for image captioning and all, it can be used. So all these models and data set you can explore in your free time. Okay, so let's see. When we load our model, this is the model, and if we provide any text, it will give us embedding. So I put this is a lab session on NLP. It provide you 1212 318. Basically these are its embeddings, and to decode these embeddings, there is a function tokenizer.decode. Okay, we are going to generate 50 tokens from the in the earlier sentence we put this is a lab session on NLP. So what it predicts we have to see. So these are the all tokens it have predicted, but what it means we can't see any number. We see there are numbers but not words. We can't understand its embedding. We have to decode it. So this is lab session on NLP. The first part of session is about NLP. The second part is about NLP. Yeah, these are the predicted embeddings. So we are going to fine tune a model, and the data we are going to is wiki text tiny. This is the data set we are going to use for fine tune. So these are the data path we get. It's stored in fast AI directory. This is train file. Let's see. So this is the data. It's Since these are random articles. What we are doing here is we are mixing all the text in the training and testing doc also. It stuck. Okay, so this is it. Yeah, this is the class defined for tokenizer. Basically, what it converts, encoder and decoder are included in this class. Encoder gives from words to tokens, and it in decoder part it decodes to sentences. Let's load our data. This is the size of one batch only. There are we set batch size 4, that's why it's 4, and sequence length is 256. Here we set already. So this is sampling. Each time you load the data and run the cell, you will get different samples. So this is class drop off. Here I have used matrix perplexity. The model is training. It will take a lot of time. Till the model is training, you guys can explore the previous problem, sentiment analysis problem. हम्म हम्म, हाँ, बेसिक इंग्लिश कॉर्पस। बेसिकली जैसे मैंने कहा कि टोकनाइजर्स में यूनिक वर्ड्स होते हैं, तो ऐसे ही ग्लोव एम्बेडिंग में बेसिक इंग्लिश नाम की एक कॉर्पस बनाई। एग्जैक्टली उसमें जितने भी डिक्शनरी में यूनिक वर्ड्स है, उसमें वो इंक्लूड किए गए, और उसकी एम्बेडिंग एनोटेशन के साथ। हाँ हाँ। हम्म It's about 38% loaded, but still it's taking a long time. All participants, you can try on IMDb dataset. This is inbuilt dataset. So same problem you are going to try with this IMDb. This is official documentation I have projected. For the online people, I have provided a link. You have to perform sentiment analysis on this. ये क्या पूरा स्क्रीन शेयर हो सकता है? पूरा स्क्रीन ये तो शेयर हो रहा है क्या मीट पे? आर यू टॉकिंग मीट ऑनलाइन? ओके ओके, ऑनलाइन ओके. ओके. Anyone had done? Okay, finally this problem is solved, I guess, for the text data. Yeah, I told you earlier it almost 1.25 lakhs comments there in the data set. And if we take value count, only non-toxic comments are 125,000. So here we perform data sampling. What we have did is we have done a new data set and concatenating the toxic and non-toxic samples after sampling them to 15,000. And actually we have 1,25,000 samples of non-toxic data only. So what we did on the basis of that, we first convert them into binary classes. Either the data is toxic or non-toxic by mixing other classes. And from the non-toxic data, we pick only 15,000 samples. Then again, these 15,000 samples, we joined them with original data. So we get the other classes as well and this non-toxic samples as well. Hmm. So this is the visualization of the data. And yeah, we perform pre-processing, text pre-processing using library RE. Basically this is to remove the unnecessary things in sentence. Then we load data, drop the null values. Then we added the pre-processed data to the comment text column. And later we divide into train and test features. We put the testing size as 20% of the total data. And here we load the glove embedding. This is 862 MB. So this is so time taking. This is our vocabulary basically, glove embedding. Okay. Now next part is to encode the sentences. This is the function to convert sentences to indices. This is LSTM model. We set embedding matrix as vocab vectors here. This is train data set. We initiate the train loader and model parameters. We have used BC loss. Let's start training loop. I don't think it's possible to complete train it completely. No, actually, we have to end today's session by 3:30. After 3:30, yes, yes. For training, it's going to take time. Yeah, it is going to take because our embedding matrix is so large. It's not possible on this collab. Though I have enabled the GPU, let me tell you, you guys can enable GPU in collab with runtime. Here, if you switch on change runtime to GPU, you can enable it. Colab provides you basic computation unit with some 12 GB of RAM and something GPU. No, no, no. When we change the runtime to GPU, it restarts the complete session, so we cannot see switch in between. And after training, the next step will be evaluation. So let it train. It's almost 3:30. So you guys have to take. You can take break up to 3:45. On from the 4 there will be session start from to the conference room of Dr. Aditya. So you have to be there. Okay, guys, we will meet tomorrow. You have session from 4, so you have to come back here at 4 o'clock. Till that, you can take a break.